Good morning, Bali and colleagues. As a co-founder of the Asia Pacific Clinical Nutrition Society, I'm particularly pleased to talk with you this morning about the future of clinical nutrition and the society itself. Perhaps the first thing to say about clinical nutrition is that it is about food intake in clinical nutrition. The way, when, where, and with whom people eat is important in its own right for health. There are presumed surrogates for intake, which we often refer to in clinical practice, several of them, but the measures in reality are determined by several factors which determine nutrient flux. Food intake itself, in all its complexity, is worthy of consideration and often essential to understand clinical problems. Its intergenerationality and place in sustainable livelihoods are of overwhelming personal, societal, environmental, and economic consequence. Firstly, of course, we have to be able to make a nutritional diagnosis. It's a clinical nutrition requisite and depends on informed awareness of the nutritional possibilities, nutrition assessment skills in a number of areas, assigning relative importance to the nutritional and non-nutritional possibilities, integrating this information and performing a probability analysis, usually Bayesian, with the appropriate logic. There have been various ways of classifying nutritionally related diseases, and one of them that's current is to classify them in these four categories: disorders affecting food or nutrient intake, growth and body compositional disorders, nutritionally dependent disorders, and nutritionally responsive disorders. Healthy eating patterns began to be promoted in public health, clinical practice, and with wartime from the late 19th to the early 20th century. Nevertheless, they were skewed, being the products of colonialism, industrialization, and monetization of food systems and nutrition science to that point. The striking appearance and epidemic of cardiometabolic disease in the 1970s ultimately led to the promotion of dietary guidelines. These were found to be somewhat inadequate, and the emphasis on food rather than nutrients was incorporated into what came to be known as FBDGs, food-based dietary guidelines, developed by FAO and WHO and formulated in the Cyprus Declaration of 1995. More recently, FAO for the UN system has developed the FBDGs further as food systems-based dietary guidelines in this compendium shown on the right here. There are various ways in which this might be an enhancement of present practice. Here is one illustration of this from this report, and it shows how a food system approach to dietary guidelines can connect with the current aspirations to achieve sustainable development goals by 2030 on the right-hand side of this diagram, and then looks at the inputs, the outputs, the outcomes, and the impact. Admittedly, this is tuned more to public health, but I would argue that this is highly relevant to clinical nutrition practice as well. A good example of how we can miss, as it were, the wood for the trees in clinical nutrition practice is that we may think that we're looking at food-related outcomes when it may be something in the system and the process by which food is delivered and ultimately eaten. And one example that we've identified in Taiwan, my colleague Huang Yichen, shows that food processing and phthalate exposure from the National Nutrition and Health Survey in Taiwan has been associated with food contaminations. It's indicating that it's not necessarily the food itself, but how it's packaged, which may ultimately generate adverse health factors, in this case, phthalate contamination of foods. And we see this increasingly with endocrine disruptors in foods coming from microplastic and nanoplastic. Clinical nutrition has evolved from early conceptualizations by our ancestors of food and health, where they were bound to nature and each other. We have developed complex and contextual sustainable livelihoods for sustenance, survival, and intergenerationality. Clinical nutrition owes its recognition to the advent of scientific thought and methods in the 17th century. Along with this, the Industrial Revolution occurred, and clinical nutrition became associated with its health problems. The International Union of Nutritional Sciences was formed in 1946 and promoted nutrition and medical education, but its explicit recognition and support of clinical nutrition was pending until 1983. The International Symposium on Clinical Nutrition began at the Royal College of Physicians in London in 1981 and became collaborative with the IUNS in the 1980s. This was supported by an Australasian Clinical Nutrition Society and the Asia Pacific Clinical Nutrition Society. The subject of this conference was formed as an affiliated body of IUNS in 1982. It then inaugurated the Asia Pacific Journal of Clinical Nutrition, a vehicle for regional clinical nutrition professionalism. Björn Isaken, who was Secretary General of IUNS and the first professor of clinical nutrition, as far as I know, in the world, wrote together with me this paper in the Lancet supporting the development of clinical nutrition and outlining how it might develop at the undergraduate and postgraduate level. And we argue that clinical nutrition was cardinal throughout healthcare practice. As this was happening, the development of clinical nutrition was happening, we became acutely aware that major changes were taking place in the food system, and this was perhaps best illustrated by evidence over 100 years that there was a dramatic reduction in food biodiversity taking place. For some things like, let's say, sweet corn, it dropped from 307 varieties to something like 40 or so varieties in 100 years. It stands to reason that this dramatic change in the food supply that was going on would have health relevance, and in ways that we were yet to recognize, since we hadn't been paying attention to the bioactive compounds in food beyond so-called nutrients, nor did we pay attention to the food structure as opposed to the nutrients or the food microbiome. So what has become apparent is that there is a relationship between dietary diversity and various health outcomes, including healthy life expectancy. And this is a universal phenomenon, although its expression does vary from place to place. This is a graphical representation of this relationship between healthy life expectancy and dietary diversity by our Japanese colleagues. Miyamoto published in 2019 in EJCN. Why is food diversity so important? Well, it's about sustainability, food quality, providing alternatives. The IUNS program in Food Habits and Later Life took the view that there were different ways in which we could eat successfully and healthfully, but the underlying commonality was food diversity. Homo sapiens, our species, as we inclined to call it, is omnivorous with a plant food orientation. Although what those plant foods are is another question. It is more likely to be micronutrient adequate. It provides dilutional effects on toxicants and contaminants like endocrine disruptors. It favors energy regulation. It favorably predicts health outcomes. And as FAO has observed and promoted, it is a measure of household and personal food security. And it may be said that clinical nutrition addresses dysfunctional human ecobiology because we are part of the ecosystem. That's who we are. The connections between every aspect of human biology and food intake require the science and practice of clinical nutrition to feature across the full scope of public health and healthcare. The recognition of our intimate cross-kingdom socio-ecology, along with the ability to manage our nutritional genomics and epigenetics, opens new vistas for clinical nutrition intra and intergenerationally, as we're certainly going to learn during this meeting. But we are threatened by unprecedented climate change originating with the Industrial Revolution, the misuse of fossil fuels, together with ecosystem loss and dysfunction. So, in the course of this development of this understanding, the concept of eco-nutrition has emerged as a framework for thinking, and the key paper which identified this approach was published back in 1998 by Ray Speck and myself. From that, we can go on to think about much of what we see in clinical nutrition as ecosystem health disorders. What are they? Well, they're manifestations of ecosystem disequilibrium, such as energy dysregulation and compositional disorders, food intake quality disorders, sensory input disorders, microbiomic disorders, biorhythm disorders, and contaminant disorders like plastics and endocrine disruptors. In the present meeting, much attention will be given as to how genomic technologies can improve and enhance personal nutrition. However, I wish to draw your attention to simpler, perhaps more accessible and affordable methods that can also help in this way. A non-invasive, modifiable, healthy aging nutrition index, HANI, can predict longevity in free-living older Taiwanese, as we found looking at nationwide representative samples of the Taiwanese population. Here, the graphs on the left show how the degree or extent of HANI can predict survival. Using this kind of methodology, we're able to see how dimensions of nutrition science, like its economic dimension, are relevant. And here, a nationwide study of elderly Taiwanese in relation to their spend on fruits and vegetables show that less expenditure on animal-derived foods and more on plant-derived foods leads to the use of less medical services and lower medical costs. And the numbers for a country like Taiwan are very substantial potential reductions in healthcare expenditure when these dietary approaches are applied. Well, coming to what many of you will be addressing during this meeting, precision nutrition, I think we need to be aware how this fits into clinical nutrition over there on the right, that pink circle, and acknowledge that this needs to proceed in conjunction with public health nutrition, the yellow circle below that, and ultimately by working towards both clinical nutrition and public health nutrition outcomes to lead to our overarching goal, that of sustainable livelihoods and indeed of a habitable planet. And over on the left, the inputs from ourselves, its persons, our ecology, microbiome, and our genomics in its various forms, genetic and epigenetic pathways, gene-diet interactions, omics technologies, and what all that means for health outcomes for both individuals and the population at large needs to be taken into account. In more detail, these are the sorts of precision nutrition interventions, I guess we can say, and all of them we need to be aware needs to feed into health outcomes. This just reminds us how that must, the sorts of factors that feed into how this will affect both individuals and the population at large. And there are some important questions of accessibility, affordability, and ethics and legal issues too that will need to be taken into account. And things like social inequity, sustainability, and governance are on the agenda. Now, the interplay between an area which we've largely neglected, I think, for 100 years, that of quantum mechanics, has relevance for quantum nutritional biology. And I think it's time for us to consider its application to food and health systems. And so we can actually put together an understanding of contemporary nutritional biology as quantum nutrition biology, but we need to consider how this affects governance, dietary patterns, and food systems. And what I'd like to suggest is that what we might be required to do is to think more about nourishment than of nutrition, because the advanced nutritional biology of a quantum kind will take into account bioenergetics, biorhythms, sensing, information and connectedness, inflammatory or inflammation and immunity modulation, integration with microbes, and indeed genetics and intergenerationality. So here's I think a timely development for clinical nutrition and for public health nutrition. Most of you will be aware that the last 2 or 3 years, a number of Nobel prizes have gone in this direction, but the application to biology and nutritional biology in particular is just emerging. So the future prospects for clinical nutrition, I would say, are challenges to nourishment intelligence, and they canvass areas of climate change, crisis nutrition, demographic change, immunoinflammatory change like pandemics, multiple antibiotic resistance, distrust of immunization and vaccination, and a greater dependence of innate immunity. That's emerging as a key area for us. Livelihood compromise, and very worryingly, unreliable information, communication and institutions, perhaps also an overdependence on artificial intelligence. Until we see just how that works, there is room for concern and action in that area. Clinical nutrition will need to have a polydisciplinary future to take account of sustainable livelihoods, quantum science, how we are nourished beyond food itself, risk management, ethical complexity, the food and health system workforce, and the realms of human and planetary security. Thank you.